Hi, and welcome to this presentation where I will talk about my dissertation thesis, Creating Value with Bioresiduals, Biogas Solutions for Bio-based Industries in Scandinavia. My name is Linda Hagman, and I have been a PhD student at the Division of Environmental Engineering and Management at Linköping University in Sweden. I have chosen this picture because I looked at agro-based bioresiduals, forest-based bioresiduals, and aquatic bioresiduals to create biogas from. We are having a problem in the world as we are using too much fossil fuels, which has sped up our climate changes and other environmental problems. We therefore have to phase out our fossil resources, and this will require us to use a lot more bio-based resources. And the bio-based resources are not only needed to create energy, we also need it for food and other products. And if we need to use much more bio-based resources, we have to assure that they will be used sustainably. There has to be a resource-efficient use of the biomass, and biogas solutions from bio-based industries residuals can be a solution to one of the solutions for this development. So when I talk about biogas solutions, I see anaerobic digestion that is used on biological substrates. And the biogas that is produced, the raw gas, it will be upgraded, or very often is upgraded to biofuel, to use in vehicles, or directly in different boilers. And we get a biofertilizer that we use to fertilize our fields. I will also talk about cascading and upcycling, where cascading is, you could say, a stair from high value products and down to lower value products. And upcycling is seen as using a low value product to upcycle it to, for example, a fuel. So very low value residuals can be used as a fuel through biogas solutions. And I will also talk about the circular bioeconomy, where I see the bioeconomy as an economy using the bio-based resources, and the circular part highlights the importance of assuring a resource efficient and a system where we get back the nutrients from our bio-based resources. The aim of this research is to understand how biogas solutions can create value and be expanded when involving bio-based industries. The research questions I have looked at in this thesis are: first, how are biogas solutions for bio-based industries commonly organized? What are the development factors to implement biogas solutions for bio-based industries? I have also looked at which effects there are for society and related actors when biogas solutions are used by bio-based industries. And last, I have studied if biogas solutions can be related to sustainability strategies within the bio-based industries, and if so, how. The theoretical framework that I've used for this thesis would be under the research area for industrial ecology. And within this field, I have focused specifically on resource-efficient bioeconomy and biogas solutions. The method for this thesis is a synthesis of my research papers. I have also developed a specific analysis method for this thesis to structure the results. I have, within my papers, used the life cycle assessment, multi-criteria assessment, material flow analysis, interviews, and case study methods. The first appended paper is called The Role of Biogas Solutions in Sustainable Biorefineries. And this was created to understand how value creation from biogas solutions are seen in biorefinery settings. And we had 3 case studies on an agricultural, 1 forest-based and 1 aquatic bio-based case, where we both did a literature review on these different types of sectors and interviews with 1 case for each sector. And what we found is that biogas solutions in these sectors are used in diverse different ways, so many solutions on how to apply biogas solutions. And the bio-based industries saw that we had advantages of reduced emissions, self-supply of energy, and improved economic situations for the bio-based industries. Biogas solutions could enable their business development, increase competitiveness, and diversify the product portfolios in the biorefineries we studied. The second paper is still a manuscript. It is at the moment called Collaboration as Enabler for Biogas Development Involving Bio-Based Industries. And this focused on how collaboration influences the determinant factors needed for biogas development. And here we used theory from the industrial symbiosis research area when applying it to the 7 cases that we have studied in Sweden and Norway. We used interviews and developed an analysis which looked at economic and market-related factors, knowledge-related, social, knowledge-related. We had institutional factors and techno-physical factors that we looked at, which are often common development factors in industrial symbiosis research as well. And what we could see is that collaboration was influencing the possibility of realizing or improving the settings for these determinant factors. And that specific factors was to have mobilizing actors, often champions with a biogas company or within a municipality, who were working hard for the biogas plant, and that long-term agreements with the bio-based industries were realizable. Well, we see that the collaboration facilitated the development in bio-based industries, and we also saw that it was common to have local actors being one of these facilitators who enabled collaboration. The third paper of this thesis is called The Role of Biogas Solutions for Enhanced Nutrient Recovery in Bio-Based Industries, 3 case studies from different industrial sectors. And again, we are using these agro-based, forest-based, and aquatic residuals. And we have studied through material flow analysis their nutrient recovery and transportation need before and after a biogas plant was implemented. So what we could see is, when comparing before and after scenarios, is that both nitrogen and phosphorus recovery improve in all cases, but it can vary on how much. The best improvement was a case which had 31% of nitrogen recovery before and 58% after the biogas plant was incorporated, and 32% of phosphorus recovery before to 96% afterwards. We could also see that transportation demand decrease because often wet residuals could be transported far away to be treated somewhere else, but when a local biogas plant was implemented, they could transport it shorter. So the conclusion is that we do see that the biogas solution improve both local nutrient recovery and or the transportation distance. In paper 4, which is called Assessment of Byproduct Valorization in a Swedish Wheat-Based Biorefinery, I look quantitatively, together with my supervisors, On the management alternative for ethanol byproducts, the stillage, I applied a life cycle assessment on this ethanol plant and had 6 scenarios on how to handle and manage the stillage. It was using it as feed directly without further treatment for pig feed, as pig feed mainly. It was using it directly as a fertilizer. There was incineration because the studied case was very close to an incineration plant. And then we had 3 biogas scenarios, which had different approaches. So we had a local biogas plant producing biofuels for vehicles. We had a local biogas plant producing electricity and heat. And there was a distant or further away localized biogas plant that was producing biofuel. And what we saw is that the local biogas plant producing biofuel was the best if we were using system expansion as instead of other allocation methods. And we could see then that the greenhouse gas emissions decreased by 57 kilogram per ton of substrate, and it was 53 for feed. So both these options are fairly good from an environmental perspective. And we also did a study on the nutrient recirculation. And when we had the local biogas plant and compared the nutrient content of the biofertilizer to the demand of fertilizer to produce the wheat, which was used in the ethanol plant, we could recover 36% of the phosphorus and 17% of the nitrogen through the biogas solution, going back to local fields again. And what we see is that when nutrient components in the residuals are low and hard to use as feed, because in this biorefinery we studied, they were extracting, for example, gluten, which decreased the protein content of the end product or end byproduct. And if the protein content was higher, perhaps feed would have a better outcome in the life cycle assessment. But therefore, biogas solutions are very competitive options for valorization if the residuals are low value for other purposes. The 5th paper is called Advancing the Circular Economy Through Organic Byproduct Valorization, a multi-criteria assessment of a wheat-based biorefinery. So we're studying the same case again, with the same 6 scenarios as I explained earlier, but we used a multi-criteria assessment where we had 19 different indicators that were assessed within the areas of performance, risk, and feasibility. So instead of only looking at, for example, the environmental performance or economic performance as previously, we have also included more qualitative and I would say feasibility related aspects. For example, how the public is seeing the development, or how large the risk is in a long term to implement different alternatives for the stillage management. The results are similar to the one in the life cycle assessment, that biogas for fuel locally and the feed options are best. But we, of course, have assessed a lot more indicators, and this multi-criteria assessment may be easier for a decision maker to use for their decisions. This paper actually developed a specific tool for biorefineries or bio-based industries to use when they are having changes in their production It doesn't only have to be biogas solutions. The tool should be possible to use for other types of development as well, because what is unique is perhaps the relation to cascading effects and nutrient recirculations, which are important aspects for a biorefinery. The sixth and last paper is at the moment called Side Stream Management in Swedish Food Industry, the Role of Biogas Solutions. And here I investigate the resource efficiency of waste management in food industries in Sweden, and if they use this as a business strategy, their residual management. It was an interview study where 12 food industries participated, and I also analyzed the results through a categorization based on the recovery and use of the residuals. So if the recovery was internally or externally used, if the recovery was internal or external, or if the use of the product after recovery was used internally or externally. The results show that biogas solutions are an attractive alternative as they are circular. Many find the financial aspects important, and the management option chosen is very often the cheapest one. But we do see that sustainability is becoming more important, and more and more actors are actually having this as an important aspect when choosing management alternative. And we see that most prefer to have external biogas plants or external actors treating their bioresiduals rather than doing it internally. The conclusions are that biogas solutions are attractive among the food industries, and they see it as a long-term strategy and focus on resource efficiency. And then we look at how the different papers are related to the research questions of the thesis. And we see that most papers contribute to several of the research questions in different ways. It's either with case examples, or it's different effects that are brought up, or if we identify strategic reasons for the biogas solutions, for example. The analysis method used for the thesis is based on an article by Magnusson et al. Called Industrial Ecology and the Boundaries of the Manufacturing Firm, where they studied the recovery of side streams and use of products. I have modified this for biogas solutions, so when I look at my cases, I identify if the recovery of side streams is performed internally or externally, and also if the use of biogas is used internally or externally. And this has been a structuring tool for all my research questions, which will be seen if you read the thesis. So I'll move on to answering the research questions. And the first one was how biogas solutions for bio-based industries are implemented, or how they look. And we see that the open solutions are most commonly used. And here we basically have a bio-based industry delivering substrate to the external biogas plant. And it's often several bio-based industries who do this. The biogas plant is then upgrading the biogas, and either use it as compressed gas or liquefy it further to be able to use it in heavy vehicles, for example. We also have closed systems where I would say there are two main ways of using this. If a bio-based industries have large amount of residuals, they can have internal biogas productions themselves and use the raw gas back into their own production facility. And the biofertilizer can be used if they have own fields or if they have raw material providers, for example, in need of biofertilizer. More commonly, maybe, is that the bio-based industry use anaerobic treatment on their wastewater and use the raw gas for internal use. The wastewater is often moving further into a municipal wastewater treatment as well, or released into a water body. And a granular sludge is produced, which can be used to start up new biogas plants. There are also outsourced alternatives where we see the bio-based industry delivering the residuals to an external biogas plant, and they then buy back the raw gas. This is common if the biogas plant is situated very close to the bio-based industry, and the raw gas can be transported in pipes. And the external biogas plant is taking care of the biofertilizer and commonly upgrade the raw gas to sell as a biofuel. The diversified alternative, where we have a biofuel industry producing the biogas themselves, but sell the gas to customers, is not identified in my study, but potentially I would say biofuel industry could be interested in this, because both the bioethanol and biodiesel production receives residuals that are useful for biogas production, and they have the customers available, or like the selling should be easier for a biofuel industry compared to maybe another bio-based industry who's not in the energy sector. And there are two options found in literature where raw gas is upgraded and sold, or when raw gas is used in a generator and heat and power is sold to external customers, and biofertilizer is sold. So these are the most common ways of organizing biogas solutions in bio-based industries, which can be a good base to understand the other results. The second question focused on which development factors for biogas solutions involving bio-based industries, and also the collaboration related to this. But here we have looked at these different headlines and studied the communication, the permit processes, the resource characteristics or market competitions and agreements, etc., to better understand how they were influenced by the collaboration. And in the analysis of this thesis, I try to identify specific factors that were more relevant for the different ways of organizing biogas solutions for bio-based industries. So in the open solutions, it's important with mobilizing actors who actually implement the biogas plants nearby. But the long-term agreements with the bio-based industries are very important for it to happen and to get investment grants and loans, for example. To find available land is extra important in the open solutions because they cannot rely on the bio-based industry's own land. We see that they need compatible substrates, the permit process can be tougher, and it's important to implement mature technology and receiving the investment grants, which is actually important for all developments. In the closed scenarios, it's often a driver to improve waste management or getting a self-supply of energy. Some also see it as a long-term competition. The available land is often easier as you can build the biogas plant on their own land. An interest in sustainable solutions and investment grants are important for the closed scenarios to happen. In outsourced scenarios, we have the long-term agreements as important to assure that the residuals will be taken care of and that the energy is provided. This secures a more local market, which could lower the risk if it's locally bound. We see that it's important with mature technology and knowledge sharing between the partners, and infrastructures is important. As I mentioned, it's commonly very closely situated. Yes. The third research question focused on the effects from biogas solutions when implemented in used for bio-based industries. And I would say I have 4 areas where it's having different effects. So as a residual management method, we see reduced waste amounts, and that it's a circular alternative to other waste management options. As a wastewater treatment, the anaerobic treatment reduces the oxygen demand. It uses less land compared to aerobic wastewater treatment. You stabilize the sludge. It's a lower chemical consumption and sludge volume reduction compared to aerobic wastewater management, and this increasing the resource recycle. As a biogas or biomethane source, we see that we replace renewable energy, replace fossil fuels, improve the energy security, reduce greenhouse gas emissions, reduce particle emissions, reduce nitrogen oxides, having less acidification, and reduced noise compared to diesel engines, at least. As a biofertilizer, we instead see that the effects are when we replace mineral fertilizers, we can recycle nutrients. We get a more diverse nutrient composition. It's an easily accessible nitrogen in biofertilizer. We see increased organic carbon in soils. The soils become more resilient, and in some cases there are inhibitory effects on plant pathogens. We see less eutrophication if the right application is performed, and we improve food security if we can circulate nutrients more locally. Then we also saw a lot of effects for the bio-based industries. And this is, for example, reduced costs or increased income when having biogas solutions, depending on how the solution is implemented, of course. We see some of the actors interviewed saw increased efficiency and competitiveness, and they also used their biogas solution as a branding point to mention how circular they are or sustainable. Others are also highlighting their biogas solutions as like long-term solution to improve circularity, having long-term partnerships, yeah, and want to improve the product portfolio, etc. And other like the idea of being able to recover their own energy and become more self-sufficient. So a lot of good effects for bio-based industries as well. The fourth and last research question looked at how biogas solutions influence sustainability of bio-based industries. And I then looked at the 12 studied food industries that was used in the paper 6 and only looked at their biogas solutions. And when the recovery of side streams for biogas is assessed, we see that almost all of the cases in some way use open solutions, which means there are external actors managing the residuals, and the biogas is used by other actors than the bio-based industry. The only option not having an open one is a beverage factory having internal recovery and internal use on their wastewater as a wastewater treatment. So we see that there are different ways, and it's very common to have different ways of managing the residuals, especially and even for biogas solutions. And if we look at the sustainability ambitions among these companies, the sustainability question has become more and more important for all of them. Some, though, have a more long-term ambition to assure a circular system, and they talk about having a more local connection with the nutrient recirculation and energy provision, while others focus on marketing, for example. But one interesting conclusion was that the actors who had very ambitious long-term sustainability strategies also saw biogas solutions as being part of that. Yes. So the discussion of this thesis is that it's divided into 3 different chapters. I looked at the relevance of biogas solutions for bio-based industries, the resource efficiency, and the implementation. And I will go deeper into those. So the relevance is that we can see an improved regional development, improved energy security and food security, more important than ever, perhaps. And biogas solutions are suitable alongside development of higher valued products. So we don't have to compete with food or chemicals. We can have biogas solutions as the final step in biorefineries or advanced bio-based industries. And we also see that networks are preferred over biorefineries to develop these different components to be sure that all actors are specialized in what they do. For the resource efficiency, biogas solutions is often an upcycling option where we use the low value residuals to actually produce some extra value. And it improves the circularity of the bioeconomy through the nutrient recovery that we see. As for the implementation of biogas solutions, we then identified that collaboration facilitates the development. It's better if it's integrated in a value chain. And we see a wide range of pathways for implementation. You can organize your biogas solutions in many ways, and it's important to make sure that the biogas solution fit to the context. So making sure that the actors providing substrates are compatible and secure. Yes. Some issues that I have come across in my research is that when having especially internal recovery of residuals, there can be operation problems that affect the main production, which is very costly. And there are some afraid of lock-in because of the long-term agreements that you have to provide substrates for more than 10 years, for example, and cannot use it for other options. But I've also learned that the biogas actors are often very flexible in as long as not the full amount of substrate is disappearing. We see some investment risk and financial problems because not all services of biogas solutions having an economic value in today's system. It can be hard to get black numbers on the first years of operation, but it often stabilizes, and especially if you use more waste-based substrates, it becomes better. We also see that transportation can be a problem. My paper 3 identified that we often shorten distances when implementing a biogas plant, but there are a lot of wet, bulky substrates and biofertilizer, for that sake, that has to be transported, especially if we have few but large biogas plants. So in those cases, we have to make sure that transportation is sustainable. So the conclusion is perhaps that many bio-based industries prefer external biogas actors to manage their residuals. We have identified several factors for development, such as a champion and long-term agreement. And the investment grants have also been quite, many have said that the project would not happen if it weren't for the governmental investment grants. We saw effects that were related to both waste management, energy provision, and nutrient recovery. This can lead to improved regional development if handled right. We also identified several good effects for bio-based industries and see that there is a potential for the biogas solutions there. And we see that biogas solutions have an important role when bio-based industries look at long-term sustainable visions. The future research that I propose is to continue to look on biogas solutions in bio-based industries outside of Sweden and the Nordic countries, because I think that there might be different incentives and regulations when going to developing countries. We also see and want to learn more about the business opportunities around nutrients to improve biogas actors' financial situation. And I also think it would be interesting to understand more about how collaboration with farmers improve the full value chain. For example, when talking to the food industries, their biggest environmental impact lies within the food production step. So if they can somehow recirculate the nutrients and replace maybe both energy and nutrients through biogas solutions, they can reduce the environmental impact in that step. So looking at the value chain will be very interesting in the future. Thank you so much for listening. It's been fun that you stayed for so long, and I hope you find the research interesting. Thanks a lot.